This lesson is on adding and subtracting polynomials. So let's talk about the process. If we are looking at the following, 3x squared plus 2x squared, what will that be? Well, looking at this, we can identify that there is a common factor of x squared to both of these pieces. So in essence, what I can do is I can factor out the x squared. And what's left? If I divide x squared out of the first piece, 3x squared divided by 3x squared is 3, plus divide x squared out of the second piece, 2x squared divided by x squared is 2. And you'll notice I have x squared times 3 plus 2, and if we would distribute x squared times 3, 3x squared, x squared times 2, 2x squared. That's what we started with. So putting this together, then, what do we have? X squared times 3 plus 2 would be x squared times 5, or 5x squared. And of course, that seems to make sense, doesn't it? 3x squared plus 2x squared is going to be 5x squared. Think about it this way. 3 square miles plus 2 square miles is 5 square miles. Now, where it gets interesting, though, is when we do not have like terms. For example, if I have 3x squared plus 7x, these are not like terms. If I want to play that factoring game, I could do it. If I factor out an x, because there's an x common to both. Factoring an x out of the first piece, 3x squared divided by x is 3x, plus 7x divided by 7 is 7. There's nothing else I can do with this. I can't simplify this. So these are not like terms. That's the best I can do with something like that. So the only way they're like terms is if the variables are the same and the powers are the same. There's one other case that gets a little interesting. If I have 5x squared plus x squared, how do I make sense of this? How do we think about this process? Well, there's an x squared common to both, so let's play that factoring game again, just to think about what this means, what it represents. Each of these terms has a common factor of x squared. So if I factor out the x squared, what am I left with? 5x squared divided by x squared is 5, plus x squared divided by x squared, anything over itself is just 1. So we get x squared times 6, which is 6x squared. Now, the simpler way to get there, recognize we started with 5x squared plus x squared. Let's instead make that 5x squared plus 1x squared. If there's no number in front of the monomial, in front of that term, I can go ahead and put in a 1, because x squared is the same as 1 times x squared. Now, 5x squared plus 1x squared, I think you can see is going to be 6x squared. So the key idea is we add like terms. Now, what are like terms? Same letters, same powers. So if I have 3x squared plus 5x plus 2x squared, 2x squared plus 7x minus 3 plus x. We look for like terms. Now, my strategy is to underline the like terms. 3x squared plus 2x squared. Are there any other x squareds? 3x squared plus 2x squared is 5x squared. Then let's look for the x's. We have 5x here, double underline the x's, 7x here. And this is an x. There's no number in front of it. I'm going to put a 1x there just to make it a little clearer. 5x plus 7x is 12x, plus 1x is going to give me 13x. And then for the minus 3, we'll make that plus negative 3. And that's the only number. So plus negative 3, which again would be the same thing as minus 3. You want to write it that way, 5x squared plus 13x minus 3. So adding like terms is our idea. Now we can have more complicated terms. For example, I could have 5x squared y minus 2 xy squared plus 7x squared minus x squared y plus 4 xy squared plus 3x squared. So we're looking for like terms here. I like to put ones in just to keep track of that, and I like to make minuses plus negative. So I'll make this plus negative, and I'll make this plus negative, and we'll look for like terms. So here's the x squared y term. There's 5x squared y. Do we have another one? Here's negative 1x squared y. 5x squared y plus negative 1x squared y would be 4x squared y. Now let's look for the xy squared terms. There's negative 2xy squared and positive 4xy squared. Like terms, same letters, same powers. 4 plus negative 2, 2xy squared. And then we have our x squared terms. There's a 7x squared and there's a 3x squared. Add those together. And what do we get? We get 7x squared plus 3x squared is going to give me 10x squared. So we look for like terms and we add them together. Now, typically, our most simple or simplest polynomials are things that look like this. 4x cubed plus 2x squared minus 7x plus 1 plus 3x cubed minus 9x squared plus 7. So now I have two polynomials with descending powers of x here, polynomials with descending powers of x there. If there's addition between them, I can just write them without the parentheses. Now, if there's subtraction between them, it's going to be a different story. So if there's addition, I can just add the two pieces together and not worry about the parentheses. But I still argue that we should change the minuses to plus negative. Make this plus negative. Make this plus negative. Make sure I copied it down correctly. 3x cubed minus 9x squared plus 7, 4x cubed plus 2x squared minus 7x plus 1. Good. Now, adding the like terms, let's look for the like terms. I like to underline them. 4x cubed and 3x cubed. Those are the only x cubes I see. 4x cubed plus 3x cubed is 7x cubed. Then let's look for the x squareds. 2x squared and negative 9x squared. 2 plus negative 9, negative 7x squared. A lot of 7s in this problem, because look at what I have next. Now I have x's. How many x's do I have? I only have this one right here. That's the only x that I have. So that's plus negative 7x. And finally, we get one that's not going to be a 7. What do we have here? We have 1 plus 7. I'll do a little squiggle underline for the numbers. 1 plus 7 is 8. And the advantage to my underlying scheme is it makes sure I didn't forget anything or miss anything. Now, these plus negatives in a solution manual or in a computer-graded homework, they're going to want you to write this as minus 7x cubed minus 7x squared minus 7x plus 8. That is that process. Now, what if we're subtracting polynomials that look like this? So again, let's look at descending powers, and we're going to subtract. So if I have 4x squared minus 3x plus 2 minus 6x squared plus 7x minus 9. So now we're subtracting polynomials. This gets a little bit trickier. Okay, step one, I'm going to change the minuses to plus negative. So this will be a plus negative here, and this will be a plus negative here. And then I also have a minus here. This is the trickier one. We'll make this plus negative, but then this negative has to distribute to all of those pieces. So what am I going to have? I'm going to have 4x squared plus negative 3x plus 2 plus the negative of 6x squared, the opposite of 6x squared, negative 6x squared, plus the opposite of 7x. The opposite of 7x is negative 7x, plus the negative of negative 9. The opposite of negative 9 is positive 9. And then at this point, we're going to look for like terms. 4x squared and negative 6x squared. 4x squared and negative 6x squared would be negative 2x squared. Then we're going to look at the x's, who's in the x group. Negative 3x and negative 7x would be negative 10x. And then finally, we're going to look at 2 plus 9, our numbers. 2 plus 9, and it'll become plus 11. Again, you see my scheme for underlining. And then just change the plus and negative back to minus to make the computer-graded systems happy. Negative 2x squared minus 10x plus 11. Now, it is possible to do a little bit of addition and subtraction for these polynomials. So let's take a look at that kind of a situation. What if I have x squared minus 3x plus 2 plus 4x squared plus 7x minus 5 minus 8x squared minus 4x minus 6. So I'm doing some addition and some subtraction. How are we going to handle this? Well, I like to have a 1 here. So I'm going to put a 1 there. Anything else need a 1? I don't think so. I like to change minuses to plus and negative, make that plus and negative, make that plus and negative, make this plus and negative for the whole parentheses, make this plus and negative, make this plus and negative. And let's rewrite that so we don't miss anything. So now I have 1 x squared plus negative 3x plus 2 plus 4x squared plus 7x plus negative 5 plus the negative out in front, and inside the parentheses I have 8x squared plus negative 4x plus negative 6. And then the next thing I have to do is I have to distribute this negative sign into all of these pieces. So now where am I? 1 x squared plus negative 3x plus 2 plus 4x squared plus 7x plus negative 5 plus. Distribute the negative on the x squared. The opposite of 8x squared is negative 8x squared. The opposite of negative 4x become plus positive 4x. And the opposite of negative 6 becomes plus 6. And so when you're adding, again, this is an addition at this point. Once I distribute that, I don't really need the parentheses. So let's write it without them. 1x squared plus negative 3x plus 2 plus 4x squared plus 7x plus negative 5 plus negative 8x squared plus 4x plus 6. And at this point, we look for like terms. 1x squared plus 4x squared is 5x squared. Plus negative 8x squared would be negative 3x squared. Then let's look for the x terms. What do we have here? We have negative 3x and 7x. It can be 4x and another 4x. Would give me 8x. And then all I have left are numbers. 2 plus negative 5 is negative 3. Negative 3 and 6 is positive 3. And that seems to be my answer. So things to remember: to add like terms, they must have the same variables and the same exponents. So 3x squared plus 5x squared is 8x squared. Those are like terms. 2x squared plus 7x, nothing you can do with those. Those are not like terms. 3x squared y plus 5x squared y. Again, x squared y, like terms, is 8x squared y. But if I said 3 xy squared plus 5x squared y. There's nothing I can do with that because the powers on the variables are different. And then remember, if I have 3x squared plus x squared, one way to get around that problem is to put a 1 in front of the x squared. 3x squared plus 1x squared is 4x squared. And if you are subtracting x squared plus 3 minus 4x squared minus 7x plus 2, my advice is to change all the minuses to plus a negative, plus a negative, plus a negative, and then distribute accordingly. So here, what do I have? I have x squared plus 3 plus distribute the negative of 4x squared is negative 4x squared, plus the negative of negative 7x is positive 7x, plus the negative of 2 is negative 2. Then look for your like terms, put a 1 in front of the x squared. 1x squared and negative 4x squared would give me negative 3x squared. Look for x's. I only have one x. Here's the only x I have, plus 7x. And then looking for our numbers, we have 3 plus negative 2. 3 plus negative 2 is plus 1.